right, the official clock here says 4:20, which on any other date might mean something else, but we're going to start the presentation. So, okay, before I leave the slide, introduction to Python. We'll come back to these slides in a bit. What kind of program should I write? He said language processing. I'm only prepared to write a fractal program, so that's what I'm going to do. So this is a command shell. We're going to start from the bottom and write a little Python program to get things started. If I do an ls, you see I've got two files. Is that big enough? Right? I've got bmp.py and fractal.py. This is falling off, isn't it? I apologize. Right. bmp.py is an implementation of a bitmap writer, a grayscale bitmap writer. It's about 106 lines of Python code, including comments, which of course we all do because we're good programmers, conscientious programmers. We're going to use that to write, to render bitmaps. Actually, you can see we've got a mandel.bmp right there. I'm going to remove that because we're going to regenerate that. Let me take this off. So I'm going to start up what's called IPython, which is a high-powered version of Python's standard REPL, the read, eval, print loop, that if you've ever used Python, you've seen the triple chevron prompt. That's the standard REPL. IPython is a bit more powerful, has built-in features like completion and highlighting a syntax and things like that. It's very nice and a good history system. So let's write our first function. So Mandel is going to take in the real and imaginary parts, or some coordinates on the imaginary plane, and I'm going to peek down here because I always forget the math. So we're going to initialize a few variables. I assume you guys don't know much Python, if any, but I think you'll be able to understand what's going on. That's kind of the point of this little exercise. So we're going to loop over the numbers from 1 to 256, inclusive. And if our x squared plus y squared ever exceeds 4.0, we're going to break out of that loop. Otherwise, we're going to do a little bit more math here, make it a little temporary. That is the real plus x squared minus y squared. We're going to have our y get updated to be the imaginary part, plus 2.0 times x times y. And then we're going to set x equal to the temp that we created. So again, if you've done any sort of programming in any imperative language, or really any language at all, none of this should be terribly shocking. And then we're going to return the int cast of math.log of I times 256. This is the part I always forget. You know, where do I do my logs? And log of 256, and then all that minus 1. Why is that not completing for me? I have left out something. Let's try that again. Yeah, there was a missing parenthesis. I apologize for that. I'm going to cheat and just pull up fractal.bmp, the full power of Emacs at my disposal. I'm just going to paste that in there. Okay, so demo effect right there. So if we run this function, we'll see, math is not defined. What is going on here? I tried to use math.log, but I haven't imported math yet. So this is one quality of Python. The function isn't really compiled per se. It's sort of executed every time. So if I import math now, and then I run my function again, I get a result. I'm pretty sure 49 is correct there. Some of you, if you have any impression of what Python is like, may look at this and go, this is a really bad idea. Nobody does math in Python because Python is incredibly slow at math, and that is in many ways true. Straight Python is not very fast compared to, say, C, C++, C#, Java, those languages. It's not designed to be. So this is for demonstration purposes only. I'm going to speed this up a little bit and avoid any more mistypings and just pull in another function. This should be pretty easy to understand as well, right? It takes in a size x and a size y. So we're going to be rendering the picture now. And a function to calculate the value at each point, at each pixel in this image. It defaults to Mandel, so f equals Mandel, so f defaults to the function Mandel, which we've already defined. So if I now run Mandelbrot and I tell it how big should it be. Let's say 1,000 by 1,000. And we'll just pass that in. It's going to run for a few seconds, calculating 1 million values, and it's some nested loops, the kind of stuff that Python really isn't that good at. But after a few seconds, we'll get out a result, I promise you. And then I'll show you maybe a way to speed that up. So we've got x now, and I can ask how long x is. It should be 1,000 long. It's a 2D array, effectively. Each of the elements in there is 1,000 long as well. Right. So now we want to actually create a grayscale bitmap. So I'm going to import our bitmap, our BMP module, and I'm going to say bitmap, write grayscale, but I have forgotten how it works, so I ask for help on that, which is something that IPython does for me. It tells me it takes in a file name and some pixels. The pixel values we've already calculated. So let's say we're going to write out to mandel.bmp, and we'll put the pixels in there. And, oh, I called that x, not pixels. I apologize. Right, so now, if I look back at this directory, I should have a mandel.bmp again. I can open that up, and we have a beautiful fractal, right? Great. The script here says applause, but maybe it's wrong. No, I'm kidding. Thank you. Let's do something really cool then. So I injected into that discussion the fact that Python is not so great at doing math quickly. It's not the kind of thing you would be wanting to do, intense calculation in, unless you know the way to do it right. One of those ways is using something called Numba. Oh, and I'm in the wrong, we'll do this at the end, because I am in the wrong virtual environment to do this. I apologize for that. Actually, no. Let's work on that. So I'm going to activate a virtual environment. A virtual environment is a part of a toolkit that you're going to have to get used to if you do Python. It essentially is a clone of your system environment, some existing Python environment that you don't want to pollute. You create your own private one, put whatever you want into it. And it's a very powerful tool, something that if you start doing Python development, you need to know about. So it's kind of the point of this whole talk, and we won't just be doing code the whole time like this, is to introduce you to the moving parts, the important things that you need to know about. You can go and learn the syntax of Python very quickly. You can learn about integers and strings and classes and stuff. I want to give you sort of a feel for what it's like to use Python. I do a lot of Python training in various formats, and I find that it's relatively easy to teach the syntax and stuff, but to give somebody a sense of what it's like to make a Python program is a different thing indeed. So this is an experiment, so I hope it works out well for us. So I'm going to work on Introduction to Python, my virtual environment. I'm going to fire up IPython again. I'm going to once again cheat. Actually, I'll just copy this entire thing, and we'll talk about it in a second. Right. So if I scroll back up, you'll see I have, well, we've lost a bit of history. The important thing to see is this @JIT. I think I can do something very fancy here. Yes. @JIT right there. That is going to just-in-time compile this function down to, I'm not exactly sure what, LLVM bytecode, I think, and make a really fast version of this. Otherwise, it's identical, literally identical to the function that we wrote before. So now, if I say x is equal to Mandelbrot, I'll just pick Mandelbrot there. Size 1,000 by 1,000, but I'm going to use Mandel fast. Right. Let me just prove to you, though, what's happened is legit. I'm going to call the original version, and again, it's going to take a few seconds to calculate the pixels, and it's going to bind that to y. While we wait here, I heat up the atmosphere around my computer by having Python do math that it's not good at. We can, as soon as it's done, any second now, compare x equals to y. Okay, so x and y are the same. The output of these functions are the same. One ran about 10, probably 20 times faster. I haven't actually timed it. And we could generate the same results. So yes, Python isn't good at some things, and that's what keeps a lot of people from using it. They feel like that it's not really adequate for general purpose computing. But the fact is, if you know the right tricks, if you know the right idioms, you can make Python quite fast, and you can generate really beautiful fractals and do all sorts of other stuff like run YouTube. So let us switch from that 2 proper slides so that everybody feels comfortable. I know presentations have to have slides, right? I am Austin Bingham. I work for and half own a company called 60 North. We are from Norway. Well, we are in Norway, I should say. I'm from Texas originally. We do a lot of Python training. We did Pluralsight courses on Python. We have some books out. We'll talk about those in a second, actually. And we do a lot of consulting with Python, and it's something that we like a lot. We try not to be language zealots. We use whatever language is best, but we often start with Python because our experience is that it's a really nice way to get started on some new project where you have to do exploration. You can move quickly, you can throw stuff away, you can have programs that only kind of half work, but because you don't have a compiler in your way, the compiler doesn't complain about the part that only half works. You just use the part that does work. There's a lot of benefits to working in Python, we found. And there are great paths to migrate from pure Python to Python plus, say, C++, or Python plus Go or D, languages that provide a good ABI for working with them. You can write the parts that you need to be fast in the appropriate language, or you can use Numba, or you can use NumPy, things like that. All of the notebooks, all of the source code for this you can get on GitHub at Introduction to Python and the 60 North GitHub. So should be easy to remember. Take a picture if you want, or just ask me later. But all the source code is available, not the slides. Let me switch the display up a bit here so I can see my presenter notes. I'm just going to do this, not mirror, then go back. Oh, look, I have an NDC talk going on right now. So I want to give you now a quick overview of the Python language. Not the syntax of it, a little bit of that, not much of it though. More like the history of the language, the ideas behind it, where it came from, what it means to use Python in a licensing sense, things like that. Python is a really big language, and we could really only ever scratch the surface of it, even in a 3-day workshop. So one of the things we like about Python, 60 North likes about Python, a lot of people like about Python, is that it's very powerful, right? It can do a lot of things. It's not just a scripting language, although I know that's very often the sense that people have of it if they haven't used it. It's another Perl maybe, or another Ruby, and it doesn't have the fighting power of C# or something like that. Another nice thing about Python is that it's very expressive and productive. How many of you know Python at all? Okay, how many of you know it really well? Good. If you raised your hand and you're in this room, I wonder why you're here. Even if you don't really know Python at all, you can probably tell what's going on in this function. I'm not expecting you to scan it and understand it, but it's very straightforward. You know, you see things like URL and URL open and for-line and story and append. There's no weird terminology. It's all straightforward by design, the philosophy of the language. So it's very expressive code and very few lines of code. This goes to the internet, downloads a file, parses it, and basically makes a list of all the words it finds in that. All right? And so you can do all that in about, I don't know, 6 lines, 7, 10 lines of code, whatever that is, plus a doc string. And that leads to a very productive experience. Once you get Python in your fingers, you know how to use the basic tooling that comes with the ecosystem, you can move very rapidly and start to generate code quickly to express your ideas, to get things down on paper. That's the way I like to think of it. I have an idea. I want to know, is it even viable? How am I going to approach this? I don't want to think about type systems. I don't want to have to think about compiler tool chains. I want to sit down, blow something out. I might need those other things later, but I don't want to start there. Python has a really substantial footprint in a lot of industries, a lot of parts of our industry, I should say. And one is in web shops. People use Python for lots and lots of web development. Not on the front end. There's no really good tools for that. There was something called PyJamas, I think, that compiled Python to JavaScript, but it never really took off. On the back end, though, there are some really powerful tools, some really substantial tools that are worth knowing about. Tools like Django, which you may have heard of, that came out of, I think out of a newspaper like The Guardian or something like that, something in the UK, if I've got the story right. And this lets you stand up a really powerful website with admin backends and connections to databases and all that stuff, just pretty much like that. You run one command, it kind of spits out a framework, and then you start to modify that to suit your needs. It's more sophisticated than I just made it out to be, but that's a good description of how you start with Django. There are some micro frameworks like Flask, these sort of like one Python file frameworks that then we use to generate really sophisticated websites or just little bitty microservices that spit out JSON over HTTP. Tools somewhere in the middle, like Pyramid. Pyramid is, I wouldn't call that a hybrid, but it can be super powerful or it can be little bitty. And these all work really well sitting behind other web servers. So Flask, Django, Pyramid, they can all serve themselves in some sense, but they are not Nginx, they are not Apache. But they all expose what's called WSGI, the Web Server Gateway Interface, I think it stands for. So they can all just be kind of stuck behind a proper industrial strength web server that's going to face the rest of the world. So you can spend time being productive at your desk using one of these, and then when you finally need to deploy to make, $1 billion with your cat picture website, you put it behind Nginx. Another place where Python shows up and is in fact dominant these days is in science, right? It used to be MATLAB, and still to a large degree MATLAB is very big in science, of course, but it's fading because Python can do essentially everything MATLAB can do, and it's free. And if you've ever had to pay for MATLAB, you'll recognize that that's a big win. A lot of people are coming out of PhD programs in science these days knowing Python because there are some wonderful tools for using Python, things like AstroPy. So if you're an astrophysicist, and I was about to say astrologer, but an astronomer, you probably want to use AstroPy. Maybe astrologers could use it. I have no idea, actually, what astrologers do besides telling me what I'm going to eat in the newspaper. BioPython, if you're a biologist, there's lots of Python used in genomics and things like that. NumPy is effectively the matrix implementation. It's written in C. It's very fast for doing numerical vectorized kind of calculations. This is the foundation for so much of scientific Python. And if you get into that realm, this is something you definitely need to know about. You can't avoid it. NumPy is the beating heart of much of scientific Python. Layered on top of that, SciPy. SciPy gives you a lot of general purpose scientific algorithms. You can use statistics and stuff in it. You can do like regressions. You can do all sorts of matrix manipulations and so forth. It's very big, very hairy in some places, but also a sort of unavoidable thing. If you're doing any kind of science, Python is a tool that you almost can't avoid these days. So, and it's a lot of fun to work with too. Python is showing up more and more in cloud configuration kinds of tools. You have tools like Ansible, things like, well, you can access Amazon Web Services through Boto, and there's the Azure SDK in Python. They all work really, really well. I think Salt is not exactly a cloud tool, but it's, I think it's written largely in Python. It's because Python doesn't really get in the way of people who need to write programs to glue these things together. I mean, Python kind of did come out of the scripting community in a sense, and it still shines there, and that's why these tools, especially tools like Ansible, are written in that, because there's not a lot to be gained by having, for example, a static type system, or a compiler helping you write something like Ansible. It doesn't add a whole lot of value, and Python is easy to wrap your head around if you're a sysadmin plus somebody who needs to write some code. It's a very accessible language. Python is really big in data analytics to a large degree because it's really good at drawing pictures. Pandas is not really for drawing pictures. It's really a sort of a data frame oriented sort of R style library, but it ties in really well with something called matplotlib, which is the king of drawing images. And we'll look at some images that matplotlib can draw. Really high quality stuff that you could put into some literature that you're going to publish in a journal or something like that. Really, really good stuff. We have some slightly more sophisticated, more modern rendering tools like Bokeh that kind of tie Python to rendering in JavaScript on a web page. It's a bit more dynamic, a bit more interesting, a bit more modern, and kind of fun too. You have things like TensorFlow. I'm sure everybody, that's all the rage these days. Everybody's going to do machine learning, so TensorFlow is written in Python, or at least has really good Python bindings. Scikit-learn, if you want to do machine learning, there's a lot of powerful tools built into that as well. So with Python, you can build anything. I'm not going to build a space shuttle or a pacemaker out of it, but it's a very general purpose programming language, and you can build things from small little scripts up to really big programs. And I say that from experience. I've written really substantial bodies of code in Python. And it's all these little domains, plus so many other places. I used it a lot in oil and gas, which I didn't mention here, but that's effectively a science, a money-making science, I should say. But you can do it quickly, you can do it safely, you can do it efficiently. Most code doesn't need to be super fast. Your processor is sitting still almost all the time, effectively. So if you are avoiding Python or have some sense that Python is not a language that you can use because it is inefficient, I'm going to keep hammering on this idea. You don't be fooled. Give it a chance, and you'll see that actually you can make really great programs in Python quite quickly and not sacrifice performance most of the time. So what else do you need to know about Python before you kind of start using it? What is it? Where does it come from? What kind of other people use it? What's the community behind it? So Python is open source. You can go to python.org and you can clone the Git repository and you can look through all of the Python source code and all of the C source code. And you can also, because it's written in C primarily. You can also go through the entire standard library and see how it's all bolted together and see all the gore. And there's a lot of gore in there, a lot of really ugly parts because it goes back quite a ways. Python has a really nice big community, a huge community. And this is part of what makes it so approachable for a lot of people because they know that they can go online and ask questions on Reddit or Stack Overflow or at the Python mailing list. There's all sorts of places that you can get answers. And you will find, unless you're doing something really exotic, that somebody has run into the problem you're seeing before and they can explain it and they'll do it in a friendly way. It's a really open, welcoming community. If you ever get a chance to go to a PyCon, you should. Because they're really, really fun, really nice people, and they're all there because they love Python. What was the old ad with Hondas? You meet the nicest people on a Honda, I think is what it was. Well, you meet the nicest people at PyCons, so I recommend it. Python is something that's approachable by people who maybe aren't great programmers, don't want to be great programmers, aren't professional programmers, they're just casually doing it, or they have to be able to do some programming to do their job, but they don't want to be professional full-time developers. But it's also something that's quite amenable to doing full-time work. If you are a professional programmer and you're really good at all sorts of computer science stuff, Python is still a place for you to be productive and a place for you to be able to build the kinds of things you want to build. It's generally going to stay out of your way and just do what you ask. And when you do need to kind of dig in, the hooks are there in the language for you to get down to the machine as low as you want to go. But by and large, you're floating up in the cloud, and you're very happy. Your life is good. And that's because Python is fun. This is really true. A lot of programming languages, I come from a C++ background, so maybe I'm a bit jaded, but they are not that much fun to use. They get things done, and they're maybe really good at things, but they are not pleasant to work with. Python, I find, by and large, to be very pleasant to work with. And if nothing else, let this be the motivation for you to try it out. Enjoy what you do, right? We have a series of books on Python, and you can get them at, well, this is the first one, the Python Apprentice, and we have a URL there for a discounted copy of it. It's an ebook. There's not well, there is actually a physical version of it, but this is the one that you want. So that's good for, I think, the next month, unlimited number of downloads. So spread it to your friends, tell everybody about it. It's on LeanPub. I'm pretty proud of it. It's part of a larger series, 3 books, The Apprentice, Journeyman, and Master. If you have Pluralsight access, these closely track and in fact are from the same source material as our courses on Pluralsight. Yeah, they're fun books. So Python is a programming language. You probably got that much. You understand that by now. Where does it come from? So this guy, Guido van Rossum, he's the inventor of Python. He wrote it when he was in the Netherlands well, he's Dutch, so he was in the Netherlands, and this is back in the early 90s. I want to say 91-ish. Python is reasonably old. He's still heavily involved, and he's the benevolent dictator for life. That's the title we've sort of bestowed upon him in the community. So he's still very actively involved in deciding what features go in the language, and really importantly, which features don't go into the language, and how the language is evolving, and what the standard library is going to look like. And he's had his hand on the rudder the whole time, and this has really shaped the way the language has evolved, and it made it consistent. His vision is kind of baked into the language, and that makes it a predictable language in many cases. You could sit down to try to understand how a new library is going to work, and you know that, well, Guido was involved, so it's going to work kind of the way Guido wants it to work. He's a really nice guy, really approachable, so if you ever go to PyCon again, he'll probably be there, and you can go have a beer with him. He would appreciate that. Yeah, he's the BDFL. And there is an organization called the Python Software Foundation. They own most of the intellectual property for Python. They make sure that it doesn't get infringed. They also do certain funding efforts to make sure that key features get implemented if some company is not already doing it or somebody is not doing it in the open source realm. Python is general purpose. It's not really designed to be good at one thing in particular. Maybe it was originally, but it's really grown beyond that. So you can really productively and effectively use Python in almost any environment. And that's spoken to by the fact that it's used in so many different places, right? Everything from CERN and NASA to Google and Industrial Light and Magic and all these places. Dropbox actually for a while, I think not now, but they used to employ Guido. He was there working on Dropboxy stuff and some improvements, performance improvements to Python. So Python lets you write clear, readable, and expressive code. And this really is part of the philosophy of the language. That they're explicit in almost in the charter of the language, saying that we want code to look good. They recognize a truism of our profession, which is that we read code much more often than we write it. It's much more important that we can come back to our code and understand what it does after 6 months than it is to be good for a computer to process. I don't care if my computer's happy processing my code. I care that I'm happy processing my code, ingesting it again. And so Python tries to make sure that the code you write is easy to understand, easy to parse mentally, visually, and easy to maintain as a result. There are a number of implementations of Python, typically only one of which you need to be aware of, but it's worth knowing about these other things. One is CPython. If somebody says Python, they probably mean CPython. It's the canonical implementation. It's written in C, and it is the one that if you go to python.org, that's what you get. If you install it through your package manager, it's what you're going to get. There's two others, Jython and IronPython, which target respectively Java and C#, or the bytecodes for those various runtimes. They lag behind the features in CPython. CPython is the target. And I think Jython actually is pretty far behind. IronPython might be doing okay, but I don't really track those. But they exist. And for some people, it makes a big difference. In certain constrained environments, it really makes a difference. If they want to use Python and they have access to IronPython, it makes it something that they can use. Finally, there's something called PyPy, which is a bit hard to describe. So PyPy is written in something called RPython. RPython is a subset of Python that is designed for writing. It's designed to simplify writing dynamic programming languages like Python. So PyPy is a Python implementation written in RPython, which is a subset of Python itself. And the snake biting his own tail is very apropos here. But it was a bunch of computer science nerds who said they wanted to write a perfect Python in some sense, one that's very fast. Sorry, this is getting jerked around. And does a lot of fancy jitting and things like that, stuff that the CPython implementation doesn't do. It's very, very cool. It also trails behind CPython, but it's also very, very fast and worth experimenting with if you are curious about fancy computer science concepts. There are two language versions that you need to be aware of for sure. There is Python 2, 2.7, was finished in 2010. They still put out the occasional patch, but it is going to be discontinued. The entire Python 2 line will be discontinued in 2020, I believe, 2021 perhaps. Python 3 is a set of breaking changes to the language, new keywords, new concepts, that is essentially the same language, but they took the warts and they tried to remove the warts and make it more beautiful. It is a vast improvement in the language. So if you have any choice whatsoever, you should choose Python 3. And it started about Python 3.6. That's a good, stable version there. So if somebody's trying to tell you you should be using Python 2 for some reason, you should, well, they might have a good reason, hear them out, but probably you just want to walk away afterwards because Python 2 is not where you should be starting with Python these days. Always start with Python 3. Free advice. One of the philosophies behind the way the language is built is this notion of batteries included. And the standard library that comes with Python includes all sorts of stuff for doing all sorts of stuff. It comes with, we saw earlier, stuff for handling URLs and downloading things from the internet. It comes with all sorts of parsing tools, all sorts of things working with file systems and UUIDs. And you can build really substantial programs out of just the parts that come with the standard library. And this is convenient. It means you don't have to worry very often, or in many cases, about things like package management and downloading packages and having the correct environment and stuff. You can be very productive immediately with a standard Python installation. It includes all these things and more. I don't expect you to read them all. So close out the bit of slides here by saying we want you to write, read, discover, and have an adventure in Python. It is a real experience and a real fun trip to get up to speed with Python and start making programs in it. Even if you've worked in dozens of other programming languages in your life, there's something special about Python, I think. So that is the end of the slides. We're going to go back then, as I promised, to code. Some water before we do that. Let me remirror the displays. Go back to this. So I'm now going to run something called a Jupyter notebook. You may hear it referred to as an IPython notebook. And the modern version of this is called Jupyter Lab. Is that font? Well, the font really doesn't matter in this case. I'm just going to run this, and it's going to pop up a browser tab, which I can make bigger. We're going to look at the construction of a program. As we go through this, raise your hands, ask questions. If I'm unclear, if I've left something out, I want this to be interactive or as interactive as necessary so that you don't feel lost. My hope, though, my intuition is that these things are going to be very familiar to you. I'm kind of leading you down a bit of a path to realize that you already know Python in some sense. If you've done any language with classes and functions and things like that, you know Python. It's just a bit easier than what you're used to. So we're going to write a little Zork game. Anybody here played Zork? Good people. Good. It's an ancient text game, but it makes a good target for something like this. I think I can make that a bit smaller so that we see all the code. There. Is that all right for everybody? Okay. So let's dive in. The first thing I'm going to do is create a player, right? So I say, well, class player. That's how you create a class in Python. Probably not very shocking. Then you see this little colon. Okay, that colon says I'm about to start a new block. If you've heard one thing about Python, it's probably that it's slow. If you've heard two things about Python, it's that it's slow and it uses white space, and the white space is syntactically important to the language, and that's true. When you see this colon here, it means that you're going to start to see things indented another level. And in fact, if I get to the end of this line, I see another colon and another indentation. The significance of white space means that the indentation matches what the machine is going, what the bytecode compiler is going to think of as a block of code. You cannot get out of sync. What you visually see is what the computer is going to recognize as a block. It rubs a lot of people the wrong way, but only because it's different, not because it's actually bad. And in fact, it's very, very good. All you need is an IDE that knows how to do indentation, and you stop worrying about this problem. So I'm going to encourage you to try to see past this if this is something that bothers you. Are we on time? Okay, good. But the point is, the really strong point is that what you see in terms of indentation is going to be exactly what the computer sees, exactly what the bytecode compiler sees in terms of indentation. The blocks you see visually are the blocks that are going to be there programmatically, and you cannot get out of sync. It's very nice that way. But the definition of player is very straightforward. We have this funny-looking underscore, underscore, init, underscore, underscore. I'm going to call that dunder init from now on for double underscore. That's the term of art in Python. It's effectively the constructor. It takes in self. Self is the explicit reference to the instance you're working on. It's like the this pointer in C++. You have this in C# as well, I think, something like that. So in a lot of languages, it's implicit. Here, it's explicit. And this is also part of Python's philosophy. Make things explicit rather than keeping them secret. We don't want a whole lot of magic. You could call this whatever you want. It doesn't have to be called self. It's just a standard reference to a standard object. And we set a few attributes on it. We set the inventory to an empty dictionary, and we set alive to true. So when I create a player, it's going to have a couple of attributes. Let's execute that. So I can execute that, and you can see, well, the fact that this one appeared means that this block of code has been executed in an interpreter running on the little web server. I'm going to create a new cell here and just kind of probe around player a bit. So what's going on with player? Well, we can see that player has some kind of runtime representation. And this is uncommon. In a lot of languages, C++ being a good example, the class is purely a compile time thing. But in Python, player is actually an object. I can manipulate it. I can play with it. I can change things on it dynamically at runtime. This is, of course, a double-edged sword. Too much dynamism means you can make really complex, obfuscated programs. So what can I do with a player? Well, of course, I can instantiate one. just by calling it. I call the class, gives an instance, and this then prints out some information about player. I can do simple things like, assigning it to P, and then printing P, right? Nothing complicated. I've created a simple class, I've instantiated the class, and I've done things with it. And I can ask things, I can invoke things on it. I can say, is P alive? Ah, yeah, it is alive. Well, that's really good to know. So our players start out alive. Right. There's nothing any more complicated than going on in this game class. We say class game, and we define it under init. It takes in, well, the self pointer, and then two things, a current room and a player. And we just remember the current room and the player. That's the definition of our game. Right? There shouldn't be any questions at this point. This is all very straightforward, I think. Good. It doesn't get much more complicated than this as we go on. Here, I've created a room. You can see that room subclasses from something. Well, you may not know what that was going on, but that's what's going on here. I say room subclasses from ABC. ABC stands for abstract base class, which is some other class defined in the standard library that gives it the ability to have abstract methods. So description here is an abstract method, meaning that I cannot instantiate room. It's also a property. A property lets us have attributes on a class that are backed up by functions, getter and setter functions, but the API looks like you're just accessing a regular attribute. So we're saying here we're going to have description is a function, but when the user uses description, it's going to look to them just like it's a string they cannot write to. And we're going to say that our rooms have the ability to process commands, right? So the way Zork works is you have to type in, walk north, or inflate raft, or turn on flashlight, things like that. So rooms can have special processing for commands. Great. So we've seen inheritance already, but let's use inheritance kind of in anger now. So now we're going to create a room that I could actually instantiate. I'm going to subclass from room, and I'm going to say, you give me a description, I'm going to remember that description, and then when somebody asks for the description, I will return it. This is a very common idiom to use a single leading underscore to indicate a protected member, effectively, an implementation detail. Python has no notion of protected, private, public. It doesn't have access restrictions like that. We have to be consenting adults who follow the rules, and the rule is, very often, a leading underscore means don't touch this. It's an implementation detail. So you're free to touch it, but you shouldn't, and you do it at your own peril. So a static room is a very simple thing. A llama room is not so simple. The llama room subclasses from room, and it takes an account, and that's how many llamas are going to be in that room. In this case, we're going to store that on the contents that we pass into the super constructor, the constructor of the base class, I should say. The description then, this is why we want description to be a property, because now we have to calculate what the description of the room is based on what the contents, how many llamas there are in the room. So the room is filled with some number of serene llamas, and that count comes from the contents of the room. We process commands. Well, this room has a special command. You can pet llamas. And when you pet a llama, well, there may not be any llamas in the room, in which case you're told there's no llamas. Otherwise, we get a little printout saying that the llama is happy, and then we subtract 1 from the contents of the room. The llama gallops off. Similarly, we have the bear room. Bear rooms subclass from static room, so they just have a single description, that there's a bear in the room. You can try to pet the bear. So who hasn't seen the movie Revenant? Spoiler alert, there's a bear. Right, so, and the bear does some mean things. Right, so the bear will kill you. And the bear, once it kills you, it sets your player.alive to false. That's how you die in this game. Second spoiler alert. There's a few other bits and pieces we need to start bolting stuff together. There are enumerations in Python, although they're not keyword enumerations. They're just another class. They're a fancy kind of class, but they're a class nonetheless, built into the standard library. So we have an enumeration of directions north, south, east, west. We have then some tools to help us connect rooms together. So let's first look at this. Connect takes in one room and another room, a direction, and then it does the logic to bind them together. What's interesting about room, or about connect here, is that I've specified the types. In recent versions of Python, 3, 4 onwards, I believe, you can have optional type specifications in the language. Python itself doesn't care about the types. It will never, ever check them for you, but there is a growing body of tooling that will. So if you feel in certain cases like you do need static type checking ahead of time, sometimes it just makes you feel good, you can put that in your code. And then tools like PyCharm and MyPy and things like that can tell you if you've made mistakes. They're actually quite good. Without getting into the details of what this is doing, you see also that it's calling raise value error. So Python has exceptions like most imperative languages these days. And when you run into a situation where you've got a problem, you can raise value error. So if we get to the case where we try to connect the from door that's already occupied with some other door, we can tell the user, no, you can't do that. And same with the to door. If everything is kosher, then we come down here and we connect the two rooms together in a pretty straightforward way. I'm not going to go into the details of this except to say that this is a comprehension. It's a declarative way of constructing data structures. You can make lists, dictionaries, sets, a number of various things with a special syntax in the language called comprehensions. They're often faster to create these objects, lists and dictionaries using comprehensions. And they're a very neat part of the language, but they take a lot of explanation, so I'm not going to say anything more about them. Finally, we come down to some functions that just let us play the game. Make game is a simple function that says, oh, make a couple of rooms, connect them together, create a game, and return that game. No magic there. But you can feel we're getting pretty close, can't you? We have a function for processing standard commands. And this is basically a command that can be executed anywhere in the game. Things like, give me the description of the room. Sorry, you can't see me doing that. Give me a description of the room. The inventory that I have is the player, or quit, things like that. Again, no magic. If this is kind of dull, I hope that's true. Part of what I want to show you is that writing a reasonably sophisticated program in Python isn't exciting. It's not an epic, complicated journey. It's very straightforward. Some people call Python executable pseudocode, and I hope that I've kind of made that point here. I think you all understood what's going on here without a whole lot of mental effort. It's late in the day, so you can't be exerting too much energy, right? We're all exhausted. But we're making a game, and we're about to play, actually, and this is very exciting. You should be getting all sorts of hyped up. So we now have another function called print room details. It just prints some information about the room. We have a main game loop that just loops forever until the player is dead and then returns, otherwise prints the room details, accepts some input from the user, tries to process the commands, and complains if it doesn't know what to do. And finally, we come down to actually executing the game. Now, I have not been executing the cells as we went, so let's go through and do that. I'm just going to execute everything. Okay, almost there, almost there. And now we are in a dark room. There's a door to the east and a door to the north. I advise we go north first. It's safer because it is a room full of 42 llamas. We can now pet a llama. And the llama is pleased and gallops off. His mission completed. There are now 41 llamas. Let's pet one more llama because petting llamas is solid. If you've never petted a llama, if you've never been to a llama ranch, you are missing out. They are the place to be. Let's go south then. Let's be adventurous. Oh, so there's a room with a grumpy bear, and there's a door to the west. Well, it worked on the llamas. Let's pet the bear. The bear kills us. The game is over. But we played a game. We made a game and played a game in about 20, 30 minutes. So that's a Python program for you. Now, you are typically not going to write Python programs in an IPython notebook like this, unless you work for an extremely enlightened or weird company. You're going to use a regular text editor and things like that. So I want to now take this and show you what it looks like in the real world, right? So version 0.1, hope you can see that. Version 0.1 of our program is going to be one Python file, .py file called Zork-alike, the name of our program. And it looks like this. It is literally all the code we just looked at, actually I think with a few minor changes, crammed into a single file, right? Very easy stuff. If I go to the command line and go to my v01 directory, I can say Python zorkalike.py, and it will start asking me what I want to do, right? We know how the game works, so we're gonna end it. We're gonna put ourselves out of our misery and pet the bear. Game's over, we're dead. But this is how Python exists in the real world. It's a .py file, it's a text file just like any other source code file, and I can run it with Python. There's one interesting thing at the bottom of this file, and that is, when we get there, what am I doing? I have Emacs, I can go fast. This little bit here, if dunder name equals dunder main, then run. And this is the idiomatic main block of Python programs. Basically, if I ask Python to look for the module called Zork-alike, we won't go into the distinction there between file and module, but they're basically the same thing. Name will get set to main if mine is the main module. All right, so let's again go east, pet the bear. We're out of our misery. Great. So, more often than not, though, you're not going to take all of the source code for your program and put it into a single file. You're going to break it up into some larger, well, into some parts, right? So let's see what that looks like. So v02, version 2 of our program, actually creates a package. So this is a directory structure here, in case you were a bit mystified. We have a directory called Zork-alike. It contains a bunch of Python files, and it has these dunder-init.py files. Those are an indicator to the Python runtime that this represents a package, right? A collection of Python stuff that kind of exists in namespaces. Without going into the gory details, this is how we structure Python code into hierarchies, into namespaces. And we have two packages here, actually. We've got Zork-alike at the top and rooms as a subpackage because it also has a dunder-init. So if I go, and we can look through these files a bit if you want. You can see that the bear room contains the bear room implementation. Let me just get rid of this. The llama room, oh, yep. Problem with working with Emacs is your configuration changes a lot and things just kind of happen. The llama room contains the llama room implementation. There's no magic going on. I just took the various parts of the program and put them into separate .python files, which is what you're going to normally do in the real world. So if I now come to v02 at the REPL, I see I have this directory called Zork-alike. And it has the stuff we expect to see in it. And I can say python-m Zork-alike, and it will start running the game. We know how this works. Let's just get it over with and pet the bear. Right. If I start Python, I can import Zork-alike, and I can ask it where I'm getting that from by looking at the file attribute on the module I just imported. It's coming from the directory that we're in right now. This last line here, the last thing I typed at least, is another interesting indicator about the nature of Python, where everything is an object. Modules are objects. So I imported a module, Zork-alike, and I was able to ask things about it. Again, it's not just a compile time construct. It's a thing that exists at runtime. Everything in Python is this way. So that's enough of v2. v3, version 3 of this program is just like v2, except it has some more supporting infrastructure. In particular, it has something called setup.py. Setup.py is the package file. It tells Python how to take the code we've got and construct a redistributable thing that I can put up onto a package index, for example, or give to my colleagues. Without going into the gory details, we can see a few things here. There's this setup function. That's the most important thing in here. I can, if I had any dependencies, I could specify them here and install requires. And there's a few other things, classifier, trove elements, and so forth. Extra requirements if I want to do testing, which we do because we have tests. So let's look at some tests. Tests in Python are typically very simple. I'm going to give you a piece of advice. When you set out to start doing testing in Python, use PyTest. There are other alternatives, but if you're going to start out with no other prior knowledge or constraints, use PyTest. Just remember that. That's what we use here, PyTest. The other advice I will give you is use Hypothesis. It's incredible. It is a property-based testing tool that will change the way you think about testing. It's wonderful. But you can see the tests are actually pretty straightforward. Anything that starts with the word test underscore is picked up by the scanner as a test, and it's executed. And if we want to do our true-false testing, we just use the standard assertion in the language, and we just test whatever conditions we want to test. And we can also test things like, is the right exception raised, and so forth. But there's very, very little overhead, very, very little ceremony involved in setting up these tests. And this is one of the beauties of PyTest. It's really good at getting out of your way. We're moving quick here because I'm not so concerned that you understand the details. I want you to have a good sense of the landscape. So if I've gone too fast on anything, let me know, and we'll try to clarify it. But I see no big question marks above people's heads. So let's look at the final version of this program. We've still got Zork-alike. It's exactly the way we expected it to look. But now we've got something called ZA Web. We've built a little web server that serves up the game. Let's look at what that's shaped like. It's all in effectively this file, app.py. I'm going to scroll past most of it and just show you this is the important part here. This is using a library called AIO-HTTP, which is it's a hard word to say. It stands for asynchronous IO HTTP. It's basically a very fast web server written in Python using some modern techniques. So we make an application. We construct a handlers object, which we'll look at in a second. We bind some addresses, some endpoints, some get endpoints to various functions on the handlers, and we return the app. And down here, we make an app, and we say web run app. That is how you start a little AIO-HTTP web server, right? If I scroll up here, we can see there's the handlers class, which essentially is the thing that has all the logic that handles what happens when somebody calls certain endpoints, and we do things like get the description, or we do things like is the player alive, or we process commands, all the stuff we've been doing in the game. And then there's this thing up here, processor, which is basically just a holder for the game and to make sure that the commands are processed properly. So with that quick flyover, let's go back here to v04. I need to go into ZA web, Python setup.py install. I'm going to execute the setup.py for ZA web, and that's going to install a few things. They're actually already installed, so it went very quickly. And now I'm going to back out here, and I'm going to run ZA web. So now if I go in my browser, you can see it's serving up on port 8080. Very cool. We go to my browser, localhost 8080, make it a bit bigger. Ha-ha, a web front end for Zork alike. Okay, so let's get a description. Yeah, I'm in a dark room. There's a door to the east, there's a door to the north. What should we do? We're just going to get it over with, right? So I'm going to do a command. Let's go east. And this room contains a grumpy-looking bear. What are we going to do? We're going to pet the bear. That's right. We are dead. Right. So that was a 5-minute web server serving up our game now. This is a business model, right? This is serious money now. We're talking, you put this by an Nginx and you serve it up on the cloud, we're set. So that's it for that source code. We have about 8 minutes left, I think. Let me know if I'm wrong about that. I think that's right. I'm going to look at another notebook. The second one I have is plotting. I talked a pretty good game earlier about matplotlib and how it can do this beautiful rendering. So I just want to give you a sense of what that looks like. So matplotlib is venerable, established, very good at what it does. It can be a little bit weird sometimes. If you want to make your graph do just something very specific, you have to learn the way matplotlib works. But once you ingest that, you can do some really great things. So the first thing we need to do is get some data to plot. I'm going to make this a bit smaller. I hope that's still viewable. This URL is to the voting records for the region where I live in Norway. We're going to download that using the CSV library, which is built into Python, to the standard library. We're going to open it up. We're going to pull the data in. We're going to parse it, and we're going to produce a structure that maps region names to a dictionary of party names to percents. Just the data, right? So let's see if that's... Okay, that's done. So we should have all of our data. So I want to know, how did my neighborhood vote? I live in a neighborhood called Koalaberg. I call it Koalaberg because I think it's cuter. And the bus stop I get off every day is Koalaberg Skola, the Koala Bear School, I call it. I get a giggle every time. So how did they vote? Who did they vote for there? Well, this is who they voted for. They voted for the Arbeiderpartiet. I'm in the US for 3 days and I can't speak Norwegian now. The Workers' Party. Høyre, the right, these guys in green, they should really be red. The Fremskrittspartiet and all these other guys who lost, basically. So, but that's the code to make that work. I have to manipulate my data to get it into essentially 2 lists. One is the percentages and one is the parties. Why am I pointing at the screen? You can't tell what I'm pointing at. One is the percents and one is the labels for those percents. I just pulled those out here, blew it up on the screen, easy peasy. And this is pretty high quality stuff. It's a bit distorted. I'm not sure why, but I think that's an artifact of the notebook we're in. Okay, well that's great, but I really want to know how the people on the islands voted, right? So there's all these little islands around where we live. And the cool trick here is Øy is Norwegian for island. So what I'd have to look for is in all the data I've got, look for the regions that have the word Øy in it, pull them out, and display some data. So I've done that. Now I've got this island data thing, and I can show you how the various parties did on the various islands. So we've got Vassøy, Østre Åmøy, Rollsøy, and Bøy Hundvåg. And you can see here how the various parties did there. Great. I also kind of want to know the transpose of that. So I want to know how did the islands break down by party, and so I can render that just as easily. Again, you can see not a whole lot of code necessary to make that. Getting this into your fingers, being able to do this is really handy when you need to convince somebody who's in a management position at a big organization, because they love charts, right? Programmers, we can be convinced by data, but fancy charts, those convince VPs, CTOs, people like that. So this is a dirty programmer trick, right? This is how we manipulate the higher-ups if we work for some big company, faceless grind company. That is about it for material. I could do, no, that's really about it. There's 5 minutes left, so the timing worked out really well. But before we end this, I want to know, are there any questions? Yes? Yeah, so that comes from a package called Numba, N-U-M-B-A. Let me find the, oh wait, it's in requirements, isn't it? Yeah. Numba. I'm not an expert in Numba, but when you see that @JIT, so that @ symbol means you're using what's called a decorator, and a decorator takes whatever function follows it and essentially wraps it in some other functionality. You can actually fully replace it, and that's what happens in this case. So Numba takes the Python source code, analyzes it, says I can make a faster version in LLVM bytecode, and then expose that back to Python using Python C API. That's what Numba does in my understanding of it. I'm not a developer on it, I just know that it's quite good at that kind of stuff. Yes? Mm-hmm. Oh, when we were driving the game through, no, that was just the simplest way I could demonstrate the web server. Yeah, you would, of course, want to put a HTML front end on things, but I was literally just showing the JSON response from the server. Yeah. No, that would be a weird way to do anything. Yeah. 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 Yes? Yeah. The standard advice we give is PyCharm. So you can go talk to the JetBrains guys out here, and then maybe they give you a free license. It's incredible. It is the best tool overall for doing Python. And there's a free version of it, and it's a quite full-powered free version of it. VS Code is quite good. If you're a masochist like me, Emacs is excellent. VI is so-so. And there's other more specialized IDEs that you can find, but PyCharm is our standard response, standard answer. It's a really incredible tool. It's what we use for our training by and large, or for video training at least. Yeah. Yeah. Mm-hmm. Oh yeah, I mean, the choice of language to use is impacted by so many different things. What company or what our clients already know, for example. So if we show up and they all know C#, we'll just use C#. But for internal projects and for clients who don't care about the language, it's just kind of where we start. But the answer is yeah, we've run into walls with Python and said it's just not going to work for this. Maybe because there's some other technology we have to use that will integrate better with other languages or whatever. There's all sorts of reasons. But Python as a starting point is often, well, it's so helpful because we can move so fast in it, and that's really what it amounts to. We can find the edges of the problem very quickly, and then decide, okay, maybe it's, we can throw that away and move on to something else. What happens more often, though, is we write a program in Python, and 90% of it is fine, and there's 10% of it that has to be faster, or that needs to integrate with some, say, C++ library. And the kind of work we do, that's very common. And it's very easy using, there's a whole array of technologies that let you very easily integrate C and C++ code, and D code and Go code at this point, into Python programs. So you take out the part that's slow or whatever, you replace it with C, everything works just fine. And you still get to keep a Python code base for most things. Yeah. I'm really happy to talk about that topic offline. I give talks on that. It's one of my favorite parts of Python. It's just something I've got to nerd it out on. So if you have questions about it, ask me. If any of you have questions about any of this stuff for the rest of the conference, grab me, and I'll be happy to talk about this. But I think we're out of time. So thank you for your attention, and I hope you get to use Python.